I want to discuss a factor in programming that you have to consider when doing competitive programming, but normally you don't. So this is often a first hurdle when you start writing program for competitive programming. You will run into overflow bugs, and there will be precision bugs, and so on and so forth. So you probably already know the range of the primitive type. So I list the Java range here. So is similar. So typically the int will represent about 2 times 10 to the 9. So negative 10 to the 9 to positive 2 times 10 to the 9. And long in Java, and so this is long in C, will be up to 9 times 10 to the 18. And in general, don't recommend using float. So just whenever you need the floating point numbers, just use double. So they can represent bigger, and both long and double, they consume, they use 8 bytes for storage. So to illustrate the problem, let's consider this following code. So what this function does, it will print power of a's from a to the 1 to a to the 2 up to a to the b. And when we print that, I compute the answer in several ways. So S1 store the power using an integer variable, int type variable. So start at 1, and every time we loop, you multiply a to this number. And S2 will you store the result using a long. And so S1 and S2, every time I compute a new power, I print that. In addition, I also print the result from using mass.pow. So this is computing the power. So it takes a double input, and return a double. So I encourage you to try this code yourself on your own machine, or find the online IDE and see what is printed by giving different input. So the next slide shows what's printed by setting A to be 61 and B to be 12. So I use the color coding in that green are absolutely correct result. So the green numbers are correct. Red numbers are totally wrong. And the yellow numbers are the ones that are almost correct, but they're not. They're roughly correct, but they're not precise. So these columns are the numbers printed when we use int type. This column using long type, and this column is using double and mass.pow to compute the power. So as you can see, when we use int type, we start running into overflow when we are doing 61 to the power of 6. So 61 is roughly 2 to the 6. So 64 is 2 to the 6. So this is 61 to the 5 is less than 2 to the 30. So that can be represented using int 32-bit 4-byte 32-bit int. And 61 to the 6, if we use 64, then that'll be 2 to the 36. So it's going to be more than what can be represented using 4-byte. So then we start running to overflow. You can see the number jump around, sometimes negative, sometimes positive. Basically, the result doesn't make sense. When we use long, we can go all the way up to 61 to the power of 10, okay. But 61 to the power of 11, we overflow. So as you can see, this is definitely not the correct one. If you multiply this number with 61, you get something should be start with 4 something and should have 2 more digits instead of just 1 more digit. So then the overflow happens here because it's 64 bits. So, but this is something that actually but what happens with mass.pow is something that I didn't know before. It was so when I was teaching CP courses before, there was a problem that the student code did not pass, and there's no obvious reason why not. So I have to debug the code, and then finally I realized what happens is the student was using mass.power, and then the results that are computed are not precise. So if you look at here, 61 to the power of 10, the two numbers are similar, but they're not exactly the same. So you look at the last three digits, this is 560, this is 601. So the reason is both double and long, they use 8 bytes to represent the data. However, when we are doing long, then all the 64 bits are used to represent that number. But when we are using double representation, some of the 64 bits are used to represent the exponent so that we can actually represent the big number. So then, as a result, the number of bits we have to represent sort of the precision of the represent effective digit is less than long. So as a result, this is not accurate. So it cannot, the using double will enable accurate representation of, I guess, between 15 and 16 digits. So beyond that, it will not be accurate. Using long, we can represent 18 digits accurately. So using power sometimes will give you round numbers when you are doing integer. So as a result, if you are doing integer exponentiation, try to write your own code instead of using math.power, especially when the power gets bigger. So if the power is less than 10 to the 15, it shouldn't be a problem. But if it's bigger, then you could run into problem. But using double, you never overflow. So all of these are at the scale level is correct, but as you can see, we have all 0 at the end because those are really not represented by the number.